Здравствуйте, уважаемые коллеги.
Good afternoon, distinguished colleagues. My name is Anatoly Gaidansky. I am a General Director of Aero Composite. I will be moderating our discussion today. First of all, I'd like to welcome all of you and to introduce our panelists for today. I will start with Anatoly Chubais, Chairman of the Executive Board of Rusnano Company, Kirill Komarov, First Deputy Director of Rosatom Company, Alexander Tunin, CEO of Umatex Group Company, Pavel Servatinsky, Head of Metallurgy and Materials Department of Ministry of Industry and Trade, Kai Zwingenberger, sorry if I just misspell your name, General Director of Clarent Russia and SIS, and Maxim Kuzuk, CEO of RTI. And I'd like to say a few words about our today's topic about using composites in different industrial sectors. Everyone understands that in any sector of industry, in order to make some kind of leap, we have to change something dramatically, because our knowledge, basic scientific knowledge that we used in previous century and at the early 21st century, we achieved some kind of limitations. I work in aircraft industry, and I can tell you that each aircraft which we create with new consumer properties in terms of weight and other characteristics, it's becoming more and more difficult each year, because we have to use new physical principles or improve technological processes, create new materials that would allow us improve consumer properties. Today we have many heads of basic industry sectors where we have innovations and new products, and today I would like to have a panel discussion and to ask what is their perspective, what new materials or new technologies do we need, what new consumer properties we should develop in order to make a new kind of leap in technical processes and improvement of consumer properties of our products, machinery and equipment. And my first question goes to Anatoly Chubais as a head of the most high-tech companies in Russia. There is one question that concerns many of us today. We use resources that are limited in their amount. We use oil and gas. We burn when we produce energy. We burn lots of materials that affect negatively the environment. What is your perspective? Is there any new direction that might allow us decrease this negative impact of our civilization on the environment in the process of our activities? Are there any alternative technologies? Thank you for your question. I would like to say a few words about it. I think that it's really important and significant. This topic is really important. If we look at 150 to 200 years in industrial production, if we look at dynamics of production and consumption of basic resources, carbons, other sources of energy, then we might see the amazing pictures. They are similar and they are equally frightening. I do not have slides. It looks like this. It looks like this chart, this curve. And there was nothing like that. This exponential growth of consumption over the last 150 years in the history of mankind. We are dealing with our everyday problems of the current year or the current decade. But your question about materials, if we talk about materials, we have to look at a wider spans of time. This anthropogenic explosive growth of resource uses and its impact on anthroposphere in general, and its consequences for life in our planet are not quite realized until now. And it is my deep belief that when we talk about deep, profound climate changes, when we have tornado in Rostov and whirlwind in Smolensk and some hails in other countries, in other places. This is all. All these things reflect this problem. This is very big discussion, but at least we can approach the discussion. Now we should ask ourselves one simple question. What we normally discuss during all our events, we discuss artificial intelligence, blockchain, big data, deep learning, cryptocurrency, many other things. They are really important. I have nothing against discussing those things, but we have to ask ourselves: if can iPhone help us solve the problem of depleting resources in our planet? Even iPad, which I really like and use a lot, these devices, iPad or iPhone, are not able to address these issues. Why I'm talking about it? I think that the next real challenge for mankind after information and telecommunications revolution, after artificial intelligence, will be revolution associated with composites, with innovative materials. And I belong to a limited community of experts who absolutely believe in that. If we move in this direction, if we realize that we are achieving the physical limits of our planet, and if we understand that new information technology is totally a different thing, it's not about that, then we have to ask ourselves, what is the solution? In which direction we should find the solution? When we discuss directions, we discuss carbohydrates, oil and gas, renewable energy resources, which I really like. It's okay to discuss these things, but I think that energy efficiency and renewable energy is just half of the issue. And the second half is material effectiveness. We do not even have a good equivalent in Russian language, but the demand for it is really significant. If we go beyond our city, beyond our country, the demand for our children, for the next generations, is really, really high. All experts tell us that all the holistic measures to reduce global temperature increase are insufficient to prevent global catastrophe. There is brilliant Project Paris Agreement. It does not allow us to achieve the goal which is declared. And the goal is quite the goal is quite clear: 2 degrees Celsius compared to pre-industrial era. But we cannot achieve this goal. So the question is, where is the strategy? Where are our strategic directions that allow us to at least tackle this issue? It's not some kind of exotic issue. Strangely, Russia is outside of focus of the expert community. We all know the problem of refugees in Europe, and the European Union suffers a lot because of these problems, very severe problems in Italy, in Germany. But all refugees in Europe over the last 5 to 7 years, we're talking about 10 to 12 million people, according to expert assessments, in 15 to 60 years, the amount of the flow of climate refugees from Africa will exceed 200 million years. This is the story that might happen in 20 to 30 years. And if we agree that not only energy sector, but also materials can provide solution for this strategic problem of depletion of anthropospheric resources, but we have to address this problem at a far greater level. If we go down to our current situation and if we choose some practical directions for today, I see two basic directions. I'd like to underscore that we are not talking simply about new materials, not new materials that are needed for heat insulation, for space aircraft, when this spacecraft enters the upper layers of the atmosphere. We are talking about basic materials that could replace three currently existing basic materials: cement, plastic. If you look around, everything around us is made of cement and concrete, metal and plastic. These are three basic materials that we need to make dramatic changes about these three materials. We have to either replace those materials or change properties dramatically. What are possible solutions? I see two major vectors. Vector number one is composite materials. Vector number two, composite materials, I mean carbon fibers, but not only carbon fibers and not only glass, plastic, but also basalt materials. And we have not even begun to realize the importance of basalt materials. So these three basic composite materials, I regard them as breakthrough materials. As many years ago, ferroconcrete created major advancement when we combined concrete and iron, and this material has three basic properties which allowed us to change the technological paradigm in construction industry. And therefore, I think that new composites, carbon, glass, and basalt are strategic materials for technical sphere. And the second vector, which seems very unreal at the moment, but I'm ready to prove you the importance of it. These are nano-modified materials. What we have today and what we start to produce industrially, these are universal additives, carbon nanotubes, which can increase the strength of basic materials dozens of times. If we use tiny bits of, if we add tiny bits of these products, we can make titanium from aluminum. We can increase the strength of concrete twofold or threefold. Just imagine this building in which we are all sitting. It is 95%. It carries itself, and 5% it is carrying us for 5%. But this building is designed for us. If you sit in the most modern car, let it be Mercedes, and two really fat people, 500 kilograms. But what is the weight of Mercedes itself? 2,000 kilograms. If we divide, we can see that 25% is only the most modern invention by humankind. By 75% it carries itself, and only for 25% it brings us. And if we double strength parameters of concrete or metal materials, just imagine what it means. it means that the buildings will become lighter, cars become lighter. Just imagine inert materials, sand and other materials, everything that we needed to this complex technological chain, which allows us to have this building here. But we can have the same building, but twice as light. And it means that materials can save humankind. I'm sorry for my long speech.
In fact, you have spoken about a very serious issue. And I'm asking this question for a very good reason. Resources are about to be exhausted on our planet, and the human impact is very negative and can result in very negative things. And I am also a participant of developing renewable sources, and we are now developing this in a fast way. What I want to understand, if there is any potential for developing wind energy, or was it just a one-time trend because hydrocarbons are an issue here? What is your opinion? About 40 years ago, Mr. Kapitsa, who was a famous academician, wrote an article regarding renewable energy. And the main idea is the following, that there are no physical reasons to create massive renewable energy. You can find this quote in very many articles, but there is a comma after this sentence. I'm not giving you a word per word citation. If the costs are not reduced by two-digit figures, the renewable energy is not going to be feasible. If the costs for renewable energy, which means the cost price of the kilowatt of energy, has decreased even greater, it has already happened. And moreover, the energy generation that is based on coal and on gas over the last 50 years slowly and continuously is decreasing the costs for generating energy. Gas turbine gives you a 30 to 40% efficiency. And that is it. There's nowhere where we can develop that further. Renewable energy is going the opposite direction. Havil company, this is a company that produces the first Russian solar panel. It has very thin films, and the efficiency of that panel is now 22.7%, and the whole world is going the same way. It means that we have a revolution ahead of us, and that is going to give you the same costs for renewable energy as for the conventional sources of energy. But the renewable energy has a lot to attain yet. And I think that this is not a tactic, but rather a strategy. We do not have to catch up the European indicators. Over the 6 months of 2018, 40% of energy in Germany was produced from renewable sources. That is amazing. That is huge. We have 0.2%. We don't need to have 40%, but we cannot miss this huge technological cluster. And after 12 years of fight that we've started so long ago, we have amended the energy law finally, and it has started to work. What they're doing in Ulyanovsk now is very important and holds great potential. And there will be wind energy and solar energy. We were lucky and we managed to catch up, and Russia is going the same way. We are developing a full-fledged solar energy, but we're also creating the equipment for solar energy generation, including special blades for wind generators that we have. And Russia here is not lagging behind the entire world. We will have a new technological sector. It will have generation, production, and science and education at the same time. Thank you very much. Indeed, this is very important. The reasons are because every high-tech industry similar to this, like wind energy and solar energy, brings a lot of work for further subcontractors to supply the equipment, to supply the technology. Wind energy, of course, brings a great potential for fiber, for carbon fiber and for glass fiber materials. And when we produce more of these materials, it means that the cost price is going to reduce. And we hope that this area can bring a lot of benefits. My next question goes to Rosatom. Rosatom is a high-tech company, and in the world, you are the leaders among high-tech energy companies. Can we ask a question to you? From your perspective, what is going to happen in your industry? What materials do you need to develop? What will happen in the next 5, 10, 20 years? Thank you very much. In the beginning, I want to say that Rosatom now is developing atomic and nuclear energy. We are an industry, not just a company. We have more than 400 enterprises, and we employ 250,000 people, and several thousands of those people are engineers, material experts. We are now developing not nuclear energy only, we're also developing some bordering industries. The reason we do that is because we have specific ambitions. We want to have fast growth. And if we do not expand our view and do not look further from the nuclear energy, though it is the most important one, and we will try to maintain our leadership in this area in all its spheres and subfields. Another thing is that what is important for us is all the knowledge that we have accumulated. And this knowledge is to be used in other industries. Each time we try to start a new activity, we look at our industrial capabilities, because except money and finances, we can bring something new for the industry, some professional knowledge and expertise. The matter of materials here is of great importance, and I fully support the opinion of Mr. Chubais. Now there is a great hype around composites, and we can be very well developed digitally, and Rosatom does develop that. Still, hard copies mean a lot. iPad is a digital item, but it is material at the same time. If you do not have the right materials that give its peculiar characteristics to this iPad. You cannot actually sell an iPad and create some interest around it. We work in wide range of materials in nuclear energy and in other fields as well. I'll give you several examples now. We construct nuclear power stations. They are of 3+ generation, and we were the first ones to start one of these stations in the Voronezh region, and the French and the Americans are only now catching up. What's interesting is that they're actually launching their 3P+ nuclear power stations in China now, and maybe that is even a great achievement of China itself, but that is another story. These stations can be utilized for 60 years onward. That is the warranty that we provide to our customers. If this station is maintained properly and timely, the theoretical operation time of such station can be extended up to 100-year term. In order to bring that to reality, we have developed a new type of steel that it can actually withstand 100 years of operation. You can change turbines, you can replace pumps and heat exchangers, but you cannot change a reactor, because if you do that, that means that you're changing an entire power station. And our structural steel that we're using is the one that can operate for 100 years. The digital technologies that we have allow us to perform mathematical modeling, and with very high precision, we can say that such operation is possible. The use of this type of steel requires a lot of other performance characteristics from the rest of the equipment. The automatic management systems have to fall in line. Everything has to fall in line for such a station to work for 100 years. And consequently, everything that refers to the life cycle of our nuclear power stations is something that has to catch up. Now we're working on the so-called tolerant fuel. This is a type of fuel that is resistant to various accidents on a nuclear power station, and this type of fuel does not allow anything bad to happen in the station, and that employs the last developments in material studies, everything that relates to zirconium, for example. Everything is used here to make such fuel very resistant to any types of external influence. If this project is successful, then it means that we can radically change the relation towards nuclear energy. In the end of 2019, we're planning to launch this project. Our engineers and designers are now working on this. We speak about special steels and special alloys is something that not many relate to Rosatom, because they think that we work with nuclear energy only, but in fact we've been involved in this industry for a very long time already, and we have a facility in Glazov. It provides for the import substitution of titanium rolled steel, and the quality is very good, and it is also being exported now. It is certified, and there are lots of customers in Asia for these materials. Then carbon fibers, that is another area. And we also have Alexander Tuning, who is the general director of Humatex, but he will tell about this later. But we look at the pace of the development in this market. 3 or 4 years ago, we were saying, well, look at these materials. They're so promising. We understand that in order to create a composite to be used for the wing of the MS S-21 plane, we had to start at that time already. We understood that actually we have to start already, but each week producers of various goods and products speak to us, and they are interested in composites. And Alexandra will tell about it later. We study materials meticulously. There is a material institute that has been the special institute for materials since the Soviet times. They're now continuing to develop very specific materials. They're important for nuclear energy, but also for other fields. They are corrosion resistant, and they can be in use for a very long time. Another thing, we study nuclear medicine. We are the largest producer in the world of radioisotopes, and they're used to treat cancer, and we provide for 50% of the world production. Thanks to our medical expertise, we develop a new area. We have a number of very interesting developments. Some of them employ additive materials. We've been working on that as well, and that gives us an entirely new perspective on how to treat people. You have an implant that grows into your body, and it is not the human body that you actually connect with this implant, but in fact you use additive technology to connect this implant with the human body in the right way. Now, this gives us a synergy. There are new materials that we are developing, and actually there is one facility that is very close to Yekaterinburg, and that means we have additive materials, and we work together with the doctors and run tests to use these materials further in medicine. In conclusion, I would say that I do support Anatoly's opinion. The world is consuming in large volumes, consuming everything, and the pace of this consumption means that the world can become a wasteland if we do not learn to use everything efficiently. And if we do not learn to use some other and new materials, that means that at a certain point of time we will not be able to satisfy all the human needs. And that means that no matter how digital we become, I would like to repeat once again, all the hard copies of our digital technologies are still important. It means that we have to create new materials to reach new heights, and that will open up new horizons for our conventional problems, just like I mentioned for the nuclear energy.
Минуту хотел.
I'm sorry for interfering. I would like to say take 1 minute of your attention. While I was listening to him, it just came to me that Rosatom does not need any introduction. Over the last 10 to 12 years, Rosatom created second largest export high-tech potential after military technical cooperation. And this is core sphere, and there are obvious global perspectives, and 20% of power units in the Russian market, and I think that they are going to stay there. And not all of you know that Rosatom is the leading company in wind energy. The question is, why does Rosatom need these thousands of megawatts that And the answer is they are thinking about strategy, not about tactics. This is about your question. It tells us everything. We need fundamental atomic power energy sector, but it becomes diverse in our Russian realities. It's really important comment. Rosatom uses wind energy, and if Rosatom does that, it means that there is some future in wind energy. Before I give the floor to the next speaker, I would like to ask one question. We heard about additive technology. Perhaps all of you know what additive technology is. A small example. In aircraft industry, we use aluminum and titanium in large scales. What do you think? How many percentage of material that we use to produce aircraft, and how much goes to the waste? Do you have any suggestions about percentage of waste material? We do not have 20% of waste. If we do not, this is at least 7 to 8%. If we use stamping, 15 to, but we never get 20% of waste. Even if we get 80% that goes to waste product, this is about addition, using additives. If we add additives, it can revolutionize machinery industry. And I do hope that we will be able to use these additive technologies in our machinery building, and lots of machinery tools will become redundant. This is just food for mind. We use lots of composites in aircraft building. We work on Russian composites, on production of Russian composites. Everybody knows that high model, medium model, and highly durable composites, we buy those from abroad. And this sector is only several years old. And we have Rosatom's subsidiary company. Alexander Tunin is our partner, and we try to create materials that we could use in Rosatom. And I have a question. What is the strategy for company development? What materials are we going to see in the next 5 to 10 years? How do you see your export potential? It would be better to answer your question through trends of global and Russian market, because we build our strategy considering global trends. And what can we say about global market of carbon composites? 30 years ago, we had 5,000 tons of global consumption. 20 years ago, we had 15,000 tons of global consumption. 10 years ago, 35,000 tons. And last year, according to initial expert assessments, more than 80,000 tons. That is, we see that every 10 years this market doubles, and according to expert forecasts, we will see this 100 times increase. Russian market is about 400 tons. In 2017, this is about 0.5% of global consumption. We see that new industries, new sectors such as wind energy and others, by 2025, they give us real chances to increase global market of carbon composites and to achieve 2% of global consumption. How can we realize this potential globally and in Russia? There are three key sectors. Each of them comprises 60 to 80% of global consumption, and they set up trends in the world. These include car manufacturing, aircraft manufacturing, and wind energy. And I would like to give you some examples, both international and Russian, to support this statement. Aircraft industry, Boeing, Airbus, and the most modern aircraft are 50% composite. Our new liner MS-21 is 30% made of composite. Carbon composites, glass fiber are actively used in Sukhoi Superjet, new helicopter generation, and we are designing blades of aircraft engines. Last year we had very serious testing, and now we are qualifying domestic materials for aircraft building. Our Russian materials were confirmed to become comparable to American, Japanese, European materials, and I hope that within 2.5 years we will be able to undergo this difficult qualification process, and I think that in our domestic industry we will use domestic products. The second sector is car manufacturing. All the leading gigantic companies like Ferrari, Lamborghini, Mercedes, BMW, they use composites not only for designing purposes but also for car body production. And I can say with proud that 1 month ago our product was successfully tested in one of the largest company producing car parts in Austria, and they are actively dealing with composites in car manufacturing, and they concluded that our material is comparable to Japanese, to American materials. The third trend is energy wind, and Anatoly Chubais talked about it in great detail. There are two companies, Rosnano and Rosatom. These companies produce wind blades. These are 100% composite goods. This is 80% of wind unit cost, and they use carbon stiffness properties to make this blade longer and more efficient, and this project has great perspectives not only in Russia but also abroad. Our Umatex blade that we are going to perform to make 51 meter, and the next generation is 70 meter long blade. This is potential for export into Europe. Shipbuilding is another major sector, and today there is a wide range of ship building sectors that use composite materials, and we have a range of new ships 100% made of composite materials, and the body of the ship is 70% composite, and we use unique technology of vacuum infusion. Another example, today we have a passenger catamaran with 150% people capacity catamarans, and in Novorossiysk there were smaller catamarans for Asian market. It is 100% made of domestic composites from glass fiber and from carbon fiber. We also work with Italian partners to produce yachts from our composite materials. Regarding construction industry, more than 50% of energy units will. There are plans to use these composite materials for construction building, for road building, lots of other technical solutions to utilize these composite materials that allow to decrease the cost of production, to improve the lifetime of the end product. We can realize these goals all over the globe. There is a number of other trends and directions, but I would like to add that I'd like to mention sporting industry, because we know we can we can produce hockey clubs. Danis Zaripov, who became the winner of Gagarin Cup for the 5th time. 2 years ago, we started production of carbon hockey clubs, and it is analogous to European hockey clubs, but it is much cheaper. And we hope that we will be able to present this product in European market. And in last year, we started supplies from our carbon fibers from our new company in Elabuga. Over the last year, we exported more than 300 tons of carbon fibers into Asia, into Europe. It all tells us that export potential is not just existing, but it is actively implemented by a number of leading Russian companies, not only public companies, but also private ones. And in order to trigger the market, to attract new entrepreneurs and new enterprises, we initiated creation of new composite cluster in Tatarstan, in Moscow region, and in Saratov region. But also we are planning to include other regions of the Russian Federation. It unites 25% different industrial companies, institutions, universities. And the aim is to create the entire technological chain in terms of composite production, to heal all the rifts, to fill the gaps, so that our country would be able to satisfy demand within Russia, but also abroad. And another very serious project is for our forum, Composites Without Borders, which is the busiest forum in terms of foreign and Russian business. We will have the next forum in Skolkovo. It will be focusing on new composite materials, and I invite everyone to Skolkovo. I think we will have lots of interesting panel discussions and business negotiations. Thank you for your interesting presentation. It is no secret that globally new technologies cannot be developed without support of nation states, because in all sectors there is long process. This is quite a challenge, and I would like to address my next question to Pavel Servatinsky, head of Metallurgy and Materials Department, Ministry of Industry and Trade of the Russian Federation. How can we stimulate demand for these materials? How can we expand its use? And I would like to change this question a little bit. We should not stimulate demand, but we have to remove bottlenecks that prevent us from active use of composites. What do you see as your major task in terms of expansion of the market? Because the greater the market capacity, the more efficient these new products are.
Thank you very much for your question. It is actually very huge, and I will try to divide it into two parts. The investment into new materials development is quite risky, and the government is ready to provide it support by various means. The Ministry of Industry and Trade has several instruments, and now we are ready to subsidize 2/3 of the interest rates for bank loans. In the industry development fund strategy, we provide the cheapest financing. And there are also some instruments that can subsidize the R&D work. We've been using similar instruments since 2013. Our department has two special programs that develop rare earth materials and composites. And the ministry has already supported around 60 projects totaling to 9 billion rubles. What can be developed now? We have to look at the raw materials in the first place. We're looking not only into end production, we look into design, strategy, and structure. This is what can be achieved thanks to the chemical industry. Composites is also one of them, and resins, including polyether resins, are in high demand. Then the technology of manufacturing, the design of all these materials is something that is also in demand, and this work is now underway. Main problem, as I see it, is to stimulate the demand for these materials. Actually, they are still more expensive than conventional materials. I have studied meticulously all the economic indicators. Let's say you have a pedestrian crossroad. There can be various type of materials that can be used to construct a pedestrian crossing. And if you have composites, that means that you have various operational costs, and they're different from the traditional materials. We have to expand the life cycle of such materials. That is why we think that the orders have to take that into account. And we think that such procurement procedures yet do not fall in line with that, but at the same time the Ministry of Economic Development, together with the anti-monopolic agency, has elaborated special rules which are now being implemented. And I think that we have to deal with this problem in the first place. A lot has been said regarding the expertise of Rosatom. Together with them, we work in dealing with the waste, which is not actually a profile industry for Rosatom, but that is a multifaceted approach that they're taking. And maybe Rosatom will be the first company that will adopt such methods of work. Today, composites, as Alexander has already mentioned, are in demand for wind energy, transportation, gas pipelines, roads, and their promises are huge, and their possible consumption can also be huge. And maybe example of Rosatom can be very positive for Russian railways, for example. And dealing with these constraints is something that can drive our growth in terms of using composites, but other innovative materials in civil economy. Thank you very much. Now I would like to present to you our new participant, Evgeny Bacharov, the Deputy Minister of Ministry of Industry and Trade of the Russian Federation. I would like to ask you a question regarding new materials. And the main topic of our discussion is not just new materials for the sake of new materials, but rather what are the strategies, what are the materials that we will need, how can we expand the life cycle of an item? How can we expand the use of a product? You are one of the leaders from a ministry that defines the industrial strategy. What do you see as a possible application of such new materials for the next 5 to 10 years? Okay, everything what you have mentioned to reduce cost price, to expand life cycle, to extend the efficiency of a product, yes, that is everything that we aim at, but no one really knows how to do that. But that's a very important question. Actually, sometimes you do a new material just for the sake of this material. When we say to increase the demand, that means that we are not abiding by the economic strategies and theories. We need to understand what our final aim is and who the beneficiary is. So who pays for all of that? The government obviously does that because this is a strategic area. Then how efficient this financing is. And here sometimes we do not take the best decisions, and together with Anatoly, we've seen that a lot. Sometimes you have a seemingly right solution and decision, but unfortunately that does not really comply with everything what is needed in fact, and these financing becomes very risky, and that leads to losses, various types of losses. Here we need to understand what is actually in the end of this process. There are two main things regarding the Ministry of Industry and Trade. I am grateful to our colleagues from Rosnano, from Rosatom, and I think because month per month we have an open conference and we have our own agenda for this conference, and we can exchange information and resolve seemingly small issues. When we see these issues, we divide them into several areas of concern, for example, legal or technological. Then what can be done is that we can have these conferences in a public manner, in a more open manner. I really don't like it when we have some internal discussions where you have 30 to 40 people who participate in these working groups, for example. They make reports and then we don't know what's the follow-up after that conference, and I don't actually know if they do that. Well, still, actually I'm the one who receives some follow-up reports. Yeah, I knew that was the reason why you were smiling. Okay, then, now, a new perspective to spice up the conversation. We need to understand where the short-term money is coming from. When we discuss institutional development, sometimes we see that there is a solution in place and we try to actively promote a certain project. There are some areas where you use composites in the first place, shipbuilding and aviation. You can have mass demand for such materials, especially if they have a great margin. If we are able to supply a special wing to a Chinese company made of these composites, that is a great achievement, and that means that we can win at this segment of the market. Then we also speak about internal demand, but we understand that that internal demand does not fully satisfy our needs and our goals. We need to understand what is reasonable to do and what is our end result expertise, opportunities, and technological independence. We have to analyze all of that. I think that we're not actually thinking deeply enough, though the leading minds are working in this field. Still, there is no clear answer to the question why, even for me, because we come up with new questions all the time. I've been speaking quite emotionally now. I think that we, in the end, have to reanalyze our markets. Various marketing organizations are good at that. And it is not within the corporations and within the institutes where we have to discuss how to spend the money. I think such disputes are to become more public, and we need to look at the specific end products that can become very important for us. Yes, we've been discussing fibers, we've been discussing quality, and I think that I can be speaking for a very long time to use these materials for shipbuilding. Then there is another issue. We need to develop the science behind that. That is clear. This is a very complicated job, and I will actually do what is dependent on me. We will change the regulation. We will try to promote certain technologies to continue using composites. But if there are no technological changes, then we will not achieve anything. I suggest to divide the entire program of the composites strategy into specific segments. And we've already started that, and we try to make the necessary calculations, and we already understood that there are certain industries that are to be excluded. Actually, I think this is the most reasonable way. You have touched upon a very serious subject, in fact. Each project has to be economically feasible. It's hard to stimulate something that gives you losses. If the composites are still more expensive, what do we do? Well, I am sorry. We've been spending the money. Okay. We've been working for 1.5 years already. I'm actually trying to continue my point. Okay, we spend this money. We have Chinese colleagues. They say this is a governmental decision. Our new plane has to be made of 75% of the composites. And then we have decided for some reason that this project will cause losses for China, totaling to 4.5 billions. And then I don't really understand why exactly we are doing this project. Okay, but these costs are huge. I don't really understand why we have to do that, but the Chinese are very honest. They just tell you about the problems. They just say, okay, invest, but you tell them, okay, there will be losses. They say, well, you have to do that. We have to define the markets. We have to define the strategies. We need to understand how feasible these projects are. Unfortunately, when we do not defend our technological interests in the political sense of the way, that is not good. We have a lot of engineers. Actually, I think we have enough of engineers. Another thing, we have discussed the need to divide this strategy into several segments, but the Ministry of Industry and Trade cannot do that by itself. A lot more has to be done, and I am ready that our ministry is now responsible for trade offices, and I think that we can create such a network that we need. A year and a half ago, when I was still in Moscow, I made a proposal to combine certain parts and certain divisions from Rosatom. And the thing is that we can have an opportunity to receive a contract to build a nuclear power plant in a certain country. And then Rosatom, right, could be the one that does everything. And in order to promote a project, they have established contacts, they have established industrial contacts. That is actually something how we do that.
Very nice speech and really important things have been said. It's good that we started discussing that we need project and this should be profitable project because otherwise this project has no perspectives. And I hope that our applied science will also become profitable and it will work for our strategic projects. You are getting on our nerves. We have joined a digital department to aircraft department. We are trying to establish our own expertise center. And on the basis of that, we understand that we will have Hydro Aviation Salon in September. We will bring representatives. We will use digital objects because real objects are too expensive to bring to these salons. But we also should use these salons not just to talk about it, but to have some open vote, and we can then make our applied science profitable. We are ready to do that. We can try it in September and we will see if it works or not. But if there is some kind of jury, there are always someone who is dissatisfied and those who are satisfied. And dissatisfied should be also within experts. What happens with applied science when we support it? Experts vote for. If we have bids for 200 million and experts say, oh yes, everything needs funding, and then we have to call for deputy minister and ask when the normal funding of the science would start to support business processes properly. Thank you. The floor is given to Maxim Kuzuk, General Director, CEO of RTI. I know that your company is working in one interesting direction, which is going to be breakthrough direction. Can you describe your new materials and your materials? I've got my presentation ready and I need clicker. We have here a very interesting discussion. When Anatoly Chubais told us that in order to survive, the humankind needs investment into decreased use of materials in all our economic sectors. And Deputy Minister of Industry and Trade, he was talking about effective production and to be able and to attract our partners to buy from us. And in this respect, I would like to remind you one example. If you remember the origins of Silicon Valley, everyone knows TNT telecommunication company. Last century it had monopoly and it could have Bell Laboratories. And those Bell Laboratories in 1920s, 1940s, they studied semiconductor properties. And when there were attempts to disrupt this monopoly, and TNT offered to give this proprietary documents to the nation state. And based on these proprietary documents, the Silicon Valley originated. So this is, it was based on investments for decades into immature technologies by that time, but later on those technologies brought the country to the next level, to the leading positions. Therefore, we should remember that technologies should be profitable, and we should make investments into something which could bring dramatic changes. Why they act like that? Because they do not have those cycle ups and downs like we have. Both Boeing and Airbus Airbus understood that we are ahead of them in terms of infusion, and they ordered the similar equipment in Germany. And therefore, we have additional 30 passenger seats in an aircraft, which is additional money. But they also have one well-known series of 60 aircrafts per month, and they make some investments from this profit. But we do not have such series. We do not have such profits, and there is a reverse side to it. I agree with Anatoly Chubais that we cannot go without nation support of the nation state. We cannot create economic product and implement it only after that. This is complex process. We have to have these losses initially to be. Well, we still need this Chinese market. We should not abandon this partnership. We should be active to get our part of the income. But we should understand that we are not ready to become partners for economic reasons, but we are ready to cooperate, to become part of the chain. Your session is called Competitive Age in Global Markets. And if we have losses, we cannot be competitive in losses. We can create great damage, inflict great damage upon ourselves. And time is another resource. We are counting months. If we do not get the next wing, then we will not have this composite order. We will not have property. But this, our nation state, which gives investments, it does not give. It is not decision made by some deputy minister, and I am not the one who makes decision. Behind me, I should have several hundreds of market experts and professionals, engineers, who would give me support. But distribution should also be joint. Unfortunately, practice shows that a non-profitable strategic project, when we have this project, we try to distribute loads to our neighbors and try to get some profit from this non-profitable project. I hope that Deputy Minister will have time to think about early technologies, premature technologies. We have very interesting discussion, but we are a little bit behind of the schedule. Therefore, very shortly, can you please show us your presentation? I represent RTI concern, and we are working in radio informational systems and technologies. And there are certain sectors where new technologies are needed, but these are not digital solutions. And in radio informational systems, we're talking about going from media to optics. So we are trying to use abandon classical technology and to start processing information in optical range. And since in radio information technologies there is limited resources for digital technology, and we are talking about emerging talking about emerging industry of radio photon industry. And if we talk about early stage of technology development, example is radio photon circuits in in units. We know how to create these units, but the question is about materials and technologies. We need super pure materials, crystallized silicon, silicon nitride, gallium arsenide, indium phosphide, lithium niobate, germanium, and all these materials. If we do not have these materials, we cannot create these new generation systems to replace traditional radio frequency systems, to use optical range to process signals. It will create energy efficiency. It will expand our opportunities. Today, we can use these technologies. We shorten the wavelength, and we are approaching radio vision devices up to terahertz, and for that we have to develop this kind of technology. But unfortunately, this is not the issue of the 2 or 3 years. We have to unite into an industry sector to start developing these products and technologies, and we have plans for 5 years. And I think that this industry for new radio photon materials can be compared to semiconductor industry, which was deployed in USSR, but we would see tremendous effect. We would end up with emergence of several sectors, new sectors of economy that would use our new technologies. Maxim, thank you very much. I can only wish you great success, because it's too early to determine the success of this project. But if you succeed, it will be a major leap, technological leap, and in future it will have great synergistic effect. And the last speaker for today will be Kai Swingenberger. I won't ask you some questions. We have live discussion today. Just tell us what bothers you. You work in chemical industry, so tell us your view.
Thank you very much. Thank you for the invitation. My name is Kai. I represent Clariant. This is the world leader of special chemicals, or in fine chemicals as they're called in Russia. There are the slides actually that I was not planning to show right now. I'd like to tell you briefly about our history, because maybe not many know about Clariant. Our company is only 23 years old, and despite this young age, we have a very rich history. Our predecessor, like Fabrik, Rouge, and other companies are the ones that you've heard about. They've been present in the world market for a very long time. You see currently a chemical plant that was located near the Pavlesk railway station, and it produced various pigments. At that time, it was the 19th century, and at that time, blue was considered a very complicated color. Unfortunately, we have only 4 minutes for your presentation. I am sorry for limiting your presentation. So now let's speak about the figures then in this case. I would like to repeat, we are the leaders in the fine chemicals production, and our topic is innovation and new technology. And we are the leaders in fine chemicals, but also we're a highly profitable company. We are a private company, and we worked to derive profit, and we are interested in innovations. We spend 3.5% of our revenues on R&D. I think there are not many companies like that. I cannot disclose the exact figures regarding the revenues, but this is a very high share, believe me. When we look at the Russian market, there is a specific difference that we can see, and maybe after our discussion we can think about it. When we look at the patents, we see that all of them, the largest matter of them, are regarding these so-called specific chemicals. These are new materials, something for the beauty industry, some detergents, but for some reason, this segment of the market of the chemical industry is not represented in Russia. In Russia, we work in oil industry mainly. There are solutions for metallurgy sector, and the share of innovations in the field that is in demand is not that high. And the question is, where do we go? Our solutions globally aim at savings because we want to earn the money. We want our customers to make a profit as well, and sustainability is a main matter globally, but not yet in Russia. For some reason, our trade in Russia is the largest for the chemicals in commodity markets. And this is some food for thought. Where will the innovation go? We have patents that are registered now here, and in the Western countries we are working in that terms as well. We try to increase the operational temperatures, for example, and thanks to our ingredients, a lot of fuel made of Russian oil is being produced, and for some reason in Russia our main operation deals with the commodity market. This is shortly what I wanted to tell you. I can actually give a brief answer to you. I know a number of international companies. They work in Russia. I ask them the same question, and sometimes there is an opinion that maybe, okay, maybe you do not work in the right way, maybe you do not evaluate your market in the right way. Try to offer some advantages for your customers. Actually, we do not complain for diesel fuels, for example, or for the production of catalysts. For example, Russia is one of the leaders, and that underlines the importance of the Russian market for us. But I think that we have a huge potential, and our company, together with the Russian government, can develop some further advantages. Actually, what I want to say here is that maybe this is something important for Mr. Chubais. This statistics is in fact real, and it means that the demand for raw materials and the extraction of raw materials is very huge. If Mr. Chubais can actually dwell upon that, that would be good. That means that the share of special chemicals for commodity segments and industries reflects the real situation. And I think that Clariant operates according to the Russian market needs. Thanks to all of our panelists, now we can proceed with the Q&A session. My name is Yelena Belevskaya. A lot has been said about aviation. It is clear that aviation uses new materials. We see that in the West. What is the Russian situation? Actually, I have to say that I can tell about that at the very end, because now we have some other questions. We have the leaders of companies that can give responses and answers to very interesting questions. My name is Alexander. I want to ask the following question. Were there any comparisons done to compare carbon fibers and some metal materials? Carbon fiber can be used for aviation, for luxurious vehicles, for example. What if we speak about mass consumption? If we want to increase our consumption, how do composites compare to metals? Thank you very much. I mean here the financial efficiency. I'll be short. And the market is growing twofold each 10 years. The cost price of the composites falls down. The technology goes forward. Carbon fibers, for example, had a price of several hundreds of dollars per kilo. Now they cost about $15 per kilo. Luxurious market is the first market for development, and then it proceeds with the mass market. Such companies as Ford and Hyundai are now trying to employ the mass use of composites. Now they have already achieved the price of €10 per kilo. Now all the European producers want to achieve this indicator. Aviation, let's take a wing for an airplane. And you can even calculate the efficiency of this. But actually, you cannot say it for all of the issues. You have just mentioned a benchmark of €10 per kilo. I do not even know where to write that down. Can we go even further? Can we make it cheaper? If we indeed have €10 per kilo, that is a huge revolution. All the segments have the so-called black wing, and we can use that even further in the future. If we have a real need, then we are ready to use very expensive composites in order to promote a special industry. I think actually that your question was very good. If we try to zoom out and detect the major trends, the situation is as follows. The first segment for carbon fibers is aerospace industry and ballistic rockets, then aviation, Dreamliner that we spoke about, MS-21 plane, that is the next stage, then air and space, aviation, and the so-called high-tech earth industry. And here, that means luxurious sporting goods, or if we take shipbuilding, that is also something luxurious. Of course, it is a different scale, but that is a target for a 25-year timeline. It is hard to switch from metals to composites. Where is the maximum opportunity? The maximum opportunity is in reducing the price, and we think that construction is one of these segments. And what has already happened is that carbon fiber is now used to wrap a reinforced concrete column in order to provide the strength of this column. And the next stage is to replace some materials with carbon fiber. Those are power electrical lines, and then the supports for the electrified railways. But a revolutionary leap is when you switch from steel to carbon fiber. I think that is a matter of 5-10 years. If we add to that what was said before regarding vehicle construction, because now they are already making the body of cars using these composites. These are these earth markets, as I called them before, where we have to develop. You can address a specific panelist to ask your question. Unfortunately, I cannot hear the speaker because the speaker is not using the microphone. Regarding composites in electronics, what can be done? I am asking my question to whoever can give a response. The president gave us a task to create a special strategy for composites in microelectronics by October this year. And all the responses will be contained in that strategy. I have a comment, in fact. Why is Rostec not present here? We have here the leaders of new materials industry. Rosatom is here, Rosnano is here, but Rostec is not. And that could raise the quality of our discussion. And the question is, okay, new materials are great, but there is no regulation framework. How do you deal with that? The state standards do not include new notions and new materials. I will be brief. Actually, the drowning are to save themselves. Now we are constructing Petropark. We understand that the energy system of the country does not really consider how to power this park. And we define this by ourselves. We come to specific state agencies to do that. We are grateful to the Ministry of Industry and Trade. They do a lot by themselves, but I think that if businesses do not show initiative, the regulation framework cannot actually change by itself. There's supposed to be some experts that have to address this matter. They have to show that this has to be changed. And we are being active in this regard. We always address the ministries to make some changes. You have to be active. I have a short comment. I think this is not entirely right. At the end of 2017, carbon fiber and glass fiber had more than 400 standardization documents, and there were also programs for professional training that were development for this industry, and even more work is supposed to be done. So we cannot really say that there is a regulation vacuum. I have to say that we tend to make emotional decisions and emotional judgments. I want to make a comment. If you make new materials, you are the driver of regulation framework, just like in aviation. MS-21 is a plane that has a composite wing. It has never been done before. We take the regulation from abroad, we translate all these documents, we modify them to our needs, then we go to Ross Aviation Agency, and together with them we develop all the necessary regulations. It is in fact not very easy as you say. We actually once had a discussion for 6 hours regarding this composite wing. In fact, we need to go even further. MS-21 had some tests done. We are testing all these materials. And this is the first plane. It means, yes, in fact, we have to go further. And when we translate the international documents that is not entirely compliant with the Russian legislation, we're fighting legal battles to be in line with the international standards of composites and aviation, and we try to comply to the international regulation of NASA, ICAO, etc. Still, we need to understand that we need to have internal regulation, and I agree with the colleagues. Your initiative is what is needed. You just have to write all these rules.
And the last question for today. The microphone isn't working. The question to Vladimir. Were you able to achieve one of the most conventional industries in terms of artificial intelligence and hybrid intelligence, or do you still use old techniques? If I tell you that we use recept forming with artificial and intelligence, we do use artificial intelligence in our industry. We do not use any logs. Our R&D centers are leading in the world, and this was it was a prepared question, and we are going to take the very last question now. Innopolis University. It is some time ago, Anatoly Chubais performed decentralization of our ES, and this industry became more flexible, and it started developing without nation-state intervention. Is it key for competition, this kind of decentralization of Rosatom, Rostec, Rosnano? Is it maybe this decentralization would be key for further development? Let me start answering, and my colleagues would add. It might sound strange from me. You know, this answer reflects many years of difficulties, and I was initially young reformer, and now I am conventional specialist. So there is no simple answer to your question. There are lots of new breakthrough innovations that can be born outside of nation state, and there are some innovations that can never appear without nation state. And innovative economics, we cannot choose just one direction or the other. If we tomorrow integrate all our small startups into some large company, it would end up as a catastrophe. If we decentralize Rosatom, it would also end up as a catastrophe. This is not the right vector for breakthrough technology. I think that breakthrough technology should be based on the interaction between nation, state, and private initiative. Those who say that we should we should remove the state from this. So the truth is somewhere in between. We should use reasonable integration of both things. Silicon Valley would never emerged by 20 years of funding by Pentagon of research and development. The thing that we still need to learn is the correct balance. There are state corporations that are dealing with, that go forward, and there are other state corporations that are disinterested in these topics. If some big boss asks, we can just reply something. There are some big companies that are totally uninterested in this topic. Unfortunately, this topic is not the priority for the country. That is true. And in 1 hour, I'm delivering a lecture about it. Unfortunately, it means that this point of balance has not been established yet. I totally agree with Anatoly Chubai's 2 small comments. Atomic power industry is very specific. If you look globally, it is private only in the US, but we cannot say that Westinghouse company acts as private company. In all other countries, including France, Korea, China, such companies are state-owned because they address large-scale tasks, and no small company can address it. I can give you an example of ITER, a company. If my memory doesn't fail me, there are 8 countries that can do it jointly in thermonuclear project. But I agree that we should find balance, and we have found some intermediate balance. We have 250,000 talented, creative employees who bring something new, something interesting into their work every day. But even with this army of professional expert engineers, still we some time ago decided to create corporate venture foundation just with one single sole goal to find new ideas on the market, to look for young startups, to support them, to develop them. We will not replace state institutions, but we are interested in creating this bondage between what we do internally and what happens outside. And even if we are very proud of our employees, and we think that the greatest value of Rosatom is people, we understand we should be open to the outside world, and we have to interact with smaller companies, with some startups that have only ideas and no money. A very important issue. Thank you, all the panelists. In September, we are attempting the following project. We would like to take aircraft building and shipbuilding, radio electronics and microelectronics, and we want to create a number of seminars on certain conditions. If there is a company with particular tasks in particular topic, sense it's highly specialized expert, because before a designer engineer designs his own composite, it will never appear. There was a story in Komsomolsk on Amur. There was very good story of digital bath, and I asked, how can you use these digital casts? What do you do with your digital casts? I deleted. As if you remember this, there is a fun story in Siberia. Do you speak English? Asks one American to a local person, and this person says, yes, of course, but nobody needs it. Who cares? And of course, if this highly specialized experts. They only interact with boss or with or with some inferior employees. But it does not work. This person will not look for his counterparts, single-minded people. Therefore, we try to use this project to develop various tasks for specific companies. And when this person works during the day, at night, we have to protect this information. And in the morning, we can see whether it worked or didn't work. And another story is digital story. We are not answering the question why. We are not interested in why, where, how, yes, but not why. And this intellectual product the company should have rights for this intellectual product. It creates some kind of bondage for me, because when this person transforms his solutions, inputs his intellectual product, he will work using my industrial technologies. Currently, top managers are afraid of losing valuable experts. But the thing is different here. The person becomes more and more loyal to this company. And I think this kind of transformation can help us individual engineer initiatives supported by the system. Our time is up. Unfortunately, I didn't have time to tell you about aircraft industry. We will have the next session in a few minutes. I just would like to express one thought. We are talking about new materials, but it requires new patterns of thought. And this is very substantial, separate topic, and I hope next time we will be able to discuss it. Thanks for all the attendees and panelists.